Looking at this data set, we have three variables, x1, x2, and x3. The target variable is here, and you can notice all of these are binary variables. We have only 5 examples. Just visually explore if you want to predict the value of target. Which one of these 3 variables will you use to predict the value of target? If you choose x1, you can see that when the value of x1 is 1, value of target is 1. Whenever value of x1 is 0, the value of target is also 0. Right? When we look at x2, the value of 1 comes with both 1 and 0 of target. And value of 0 is quite clear. For whenever x2 is 0, we can comfortably say that target will also be 0. On the other hand, the third variable, when it is 1, x is 1. Target is 1. When it is 1, target is also 0. When it is 1, target is also 0. Similar to x2, x3 is clear. Whenever x3 is 0, target is also 0. So which one of these 3 variables will you choose to predict the value of target? Do you think x3 is better, or x2, or x1? We can make a simple rule. Whenever x1 is, the value is 1, target is going to be 1. If the value of x1 is 0, target is going to be 0. And this simple rule with one decision to check on x1 can give us correct classification. Any set of variables that give us correct classification with few checks of values will form a decision tree. A decision tree that correctly classifies all the values in training data is called consistent. So tree is consistent with examples. If we use x1, you can notice we don't need to use x2 or x3 at all. We can visually pick one variable by mapping target values with the input variable, if there are only 5 or 10 examples. But what if we have hundreds of variables and thousands or hundreds of thousands examples? We cannot do this decision tree construction manually, right? We need an algorithm that can measure, evaluate which one of the variables is good one, where to put it in the decision tree. And then after we split our data, next variable will be which one, and then next variable, and then next, like this. So at the end, we want to look at all variables one by one so that they can give us decision about class. When we put them in a decision tree structure like this, they will give us a decision about the class. So decision tree is our topic that we want to learn or induce. We want to induce a decision tree from data, not manually. But the algorithm that induces decision tree from data will be based on our intuition. Our intuition is that any variable that corresponds to the target variable perfectly or better than others, x1 is perfectly mapping to target, but in reality, we never get this kind of variable, right, that perfectly maps to target. So we need to look at combinations of variables. When we look at many variables, we need to rank them. Which one maps to target? Which one corresponds to target better than others?